So today we'll solve GET 2019 question. This is a question number 25. It is a question from functional analysis. So let L2 be a sequence space where entries are from complex number such that this is square summable, means mod xi square, and if you sum over I equals to 1 to infinity, this is finite. So this is a non-linear space with the norm is given by this. Then we have defined let G from L2 to C be a bounded linear functional defined by G of x equals to summation n equals to 1 to infinity xn by 3 to the power n for x is in L2. Then it is saying the supremum of mod gx such that norm x L2 norm of x is less than equals to 1 whole square is equals to, we have to find this, this is what. So this is basically the norm of G, operator norm of the functional G. So that we have to find. Okay. So this is the NPTEL reference. This you can check. Okay. So let's try to solve this one. So L2 is given. This is sequence space. Okay, so this is L2, and what is the norm for x is in L2? The L2 norm is given by summation n equals to 1 to infinity mod xn squared to the power half. So this will be n. Yeah. Now G is from L2 to C. So this is defined G of x to be summation n equals to 1 to infinity xn by 3 to the power n for x in L2. So you have to find operator norm of G. Gx such that L2 norm of this should be less than 1. Okay, so note that first L2, this is a Hilbert space. So first, so for that we have a ridge representation theorem. So let me write down it. So we'll use ridge representation theorem to prove this one. So let T be a bounded linear functional on a Hilbert space H. Then, so it has a Hilbert space, so it has natural inert product. So then there exists unique G in H such that T of F is given by F inner product with G for all F in H, and operator norm of T is same as Hilbert space norm of G, right? So it is saying that any bounded linear functional on Hilbert space H is given by inner, inner product with some unique function G, like this. And the operator norm of that linear functional is same as the that Hilbert space norm of that element G. So here we have this. So L2 is as L2 is Hilbert space, and this is the linear functional. So this will be given by inner product with some element in L2. So let's see what. So L2, this is a Hilbert space, and what is the inner product on L2? So this is x1, x2. And what is the for x and y in L2? The inner product is defined by xy such that summation xi yi bar. So this because here that xi and y are a complex number. And G is from L2 to C. So this is a bounded linear functional. Is bounded linear functional given by G of x equals to xn by 3 to the power n. So as this is a bounded linear functional, so it will be given by a inner product with some unique vector. By Ridge representation theorem, so this I am calling it RRT, we know G of x should be x inner product y for some unique y. So what is that element? And operator norm of G is same as L2 norm of y. So as we have G of x is summation xn by 3 to the power n. So note that this you can write summation x inner product y, where y we take this vector 1 by 3, 1 by 3 square, 1 by 3 cube, dot 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 this. And x is this vector x1, x2. So if you take the inner product x and y, you will get exactly this G. And note y is in L2 as summation 1 by 3 to the power 2n. This is finite. So by uniqueness of Ridge representation theorem, this is that y. And what will be the by Ridge representation theorem? We have norm of G, so let me call it this y naught equals to norm of y naught. So what is this norm of y naught? So this should be n equals to 1 to infinity 1 by 3 to the power 2n. And what is this? If you calculate this infinite geometric series, so it is a by 1 minus r square. So 1 by 9 and 8 by 9, so 1 by 8. Now what do you have to find? We have to find this. So note that what is the definition of norm G? Norm G is, or this functional norm of G is basically supremum of mod Gx such that norm L2 norm is less than 1. So this is same, right? That quantity, so supremum of mod Gx such that L2 norm of x is less than 1 whole square means this is norm G square, so which is same as norm y naught square, so it is 1 by 8. Okay, so what we have got this. Okay, so this we have to write in a round of 3 decimal places. So 1 by 8, if you do it in, write it in decimal expansion, so you will get basically 0.125. So the answer is 0.125. Okay.